Most container homes don't fail because insulation is thin. They fail because heat and moisture move in ways the designer didn't calculate. In extreme heat and extreme cold, steel doesn't behave like wood. It becomes a heat pump and a condensation engine at the same time.
To understand why container insulation fails, one must first accept the physics of the material. Steel is an extreme thermal conductor. It does not resist the flow of heat, it accelerates it. Furthermore, a container is a welded, semi-monocoque structure. This means the entire steel shell, the walls, the roof, the frame, is one continuous, interconnected piece of metal. There is no break. This creates a phenomenon that is the root of all insulation failures in these structures. In a container, every rib is a thermal bridge. Every weld is a heat highway. In a cold climate, this means heat from the interior will actively seek out and escape through the steel frame, bypassing the insulation. This creates intensely cold spots on the interior structure. In a hot climate, solar radiation hitting the exterior walls and roof is conducted with brutal efficiency, turning the entire steel frame into an internal radiator. This physical reality is why the most common insulation methods are guaranteed to fail. The errors are predictable. First, insulating only on the interior between studs, using fiberglass bats or foam boards. This leaves the steel frame exposed on the cold side of the wall assembly, creating massive thermal bridges. Second, failing to control vapor movement. This is the most misunderstood aspect. You don't get mold because of humidity, you get mold because steel crosses the dew point inside your wall. This is caused by a force called vapor drive. In cold climates, the high vapor pressure inside a warm, occupied home tries to drive moisture outward. In hot, humid climates, the high vapor pressure of the outside air tries to drive moisture inward. When this moving water vapor encounters the cold, conductive steel surface inside the wall cavity, it condenses into liquid water. This is the engine of failure. To defeat this in an extremely cold climate, 4 engineering rules must be followed. 1. The thermal break must be continuous and, ideally, on the exterior. By placing a continuous layer of rigid insulation on the outside of the container, the entire steel structure is kept on the warm side of the assembly, preventing it from ever reaching the dew point of the interior air. 2. If insulating from the interior, closed-cell spray foam is the only viable monolithic solution, as it adheres directly to the steel and eliminates air gaps where condensation can form. 3. The vapor barrier must be positioned on the warm side of the insulation, the interior side, to prevent moisture from the living space from reaching the cold steel. 4. Ventilated cavities between the insulation and the steel must be eliminated. They become condensation chambers. In cold climates, the steel must stay warm. If the steel is cold, condensation is guaranteed. In an extremely hot and humid climate, the physics are inverted, and so are the rules. 1. The first line of defense is external and reflective. A white or light-colored reflective roof coating is not an option, it is a necessity to reduce the initial heat load. 2. A ventilated roof cavity, or a second roof, is the most effective strategy. This creates an air gap that allows convective currents to carry away the intense heat before it has a chance to conduct through the steel. This is thermal decoupling. 3. In this scenario, the vapor barrier belongs on the exterior side of the insulation to stop the high vapor pressure from the outside air from driving inward and condensing on the cool, air-conditioned interior walls. In hot climates, the enemy is not temperature, it's heat flux through a conductive skin. The central unifying error that underlies all these failures is this: they treat a container like a framed house. But a container is a steel heat exchanger. A heat exchanger is a machine designed to transfer thermal energy efficiently. By placing insulation only on the inside and leaving the steel structure thermally connected to both the interior and exterior, a builder is fighting the fundamental nature of the object. They have created a wall assembly where invisible condensation is a certainty, leading to hidden corrosion, the degradation of the steel, and the growth of structural mold. Insulation thickness does not solve container problems. Thermal continuity and vapor control do. In extreme climates, climate is not an environment. It is a structural load that must be engineered.